different courses which you do. So if you start up with R, you have to install it. But there's another way to do R, which is Google Colab. You can search for Google Colab from anywhere if you have an internet connectivity. Use it on your phone also or on your desktop. It will work. So I'm not trying to develop an environment wherein you just need to focus on the easiest thing. Even if the explanation is hard or the syntax is hard, you can actually search for it anywhere in the Google and you will find an answer for it. So it is better. Google Colab. So I can work with Python and R, both of them in Google Colab, but right now we are doing the explanation thing. Last week we came across several algorithms. So we know a definition of it, but what does it really mean to develop an algorithm? So we will go on with it. So imagine we don't need the both of them, you just need to look at them. Imagine I have a phone book with me right now in front of you. It's a bit, so this is not a phone book, but a phone book with 1,000 pages, wherein it starts from A in the beginning, Z in the end, and it has names, contact numbers, addresses of people from India, I guess. So what we need to do is, we need to find an algorithm in order to find out the name of the person which starts with M. So what will my algorithm be? I know it starts from A here, but this is not a dictionary and therefore I do not know where A ends and B starts. I just know the beginning starts with an A, and therefore my first intuition to find out the name of a person with M, so as you can say algorithm, would be to turn the page one by one. But it is, so if I can be lucky the name of the person starts with an A, but as we move on, L, N, O, P, Q, R, S, T, it gets really hard. And therefore, if my book has 1,000 number of pages, so my algorithm would have 1,000 number of steps. So this is not optimal. This is a solution. This algorithm is a solution, but this is not an optimal solution. We need to find out the best solution for it. So an example, so you may not see a phone book here right now in the real world, but an application of this algorithm is the same as your phone book in your phone. So you have 1,000 contacts, and therefore you notice that even if you type in the name of a person that starts with an M, you are able to find it in not even a second. So if imagine I was here in front of you, I have had 1,000 name cards. It is not possible for me to do the same thing that the computer does, because this is not the algorithm that it is following. So I can optimize it if the name starts with X, Y, or Z by opening the book from the end because it starts with a Z in the back and A in the front. So, but if I have 1,000 pages, I have 1,000 n steps. Now, in another algorithm would be to turn 2 pages at a time. So it would just decrease my problem with some points, but even if it may be a bit faster than this algorithm, 1,000 steps, but this is not still the best solution which we have got right now. So how does a phone able to find out the name of the contact of any person? It follows an algorithm. So an algorithm is not the last solution. There may be another person in the next year which might come up with a better solution than me, but now we will be discussing the one which our phone books use. So we start with our book, and this is A, this is Z, and what we do is we split our problem in half. So if there are 1,000 pages in the beginning, 1,000, when I split it in half, it will be 500 in the left, 500 in the right, and if my split happens to be at O, so I split my book and I find O. So I know that M is on the left, M and O, and PQRS is on the right. And now when I started with my problem, I had 1,000 pages to deal with, and now I only have like 500 because I know that the other 500 part of the book is not my thing, and therefore I am left with 500. And then I split it into parts again. So from between A to O, imagine I land in I. So I know M is on the right, and therefore it will be 250 right now. So I will discard this part of the book, and therefore when I initially in 3 steps I was able to reach 1,000, 500, 250, and therefore when I just keep repeating this algorithm again and again, I will just reach my goal state in like maximum of 5 steps. So this is the most optimal solution which we can think of right now. There is no name for it. This is something which our phone books use, but you can just think of an algorithm to be one thing. If I consider this to be my best algorithm, I will not blindly follow it. So imagine if it starts from an A, I will still not divide the book in half. I will just start from the A and just keep on turning one page, one after the other. And if it starts from a Z, I will do the same thing, turn one page after it. But when the problem statement considers something like I, J, K, L, M, N, O, P, Q, R, S, T, I will use this algorithm. So an algorithm is not a rule for us, and it is not always compulsory for us to follow it on all the times. We need to specify which algorithm we want to use, and this is exactly what we mean by machine learning algorithms. So now you know what an algorithm means and how they start with the solution first, and then they just split it into smaller parts and find the best one. I shared spoon feed you and teach you a limited number of things, but instead what we are trying to do is trying to teach you how to find things by yourself. And the reason why I made the Google Colab was not because I wanted to teach you AI and R, but actually the machine learning algorithms would be useful in it. So if you still need to know about how R works, you can use this website, know more about it. So now, if you are done with R, we can start with another language called Python. So what we will do is compare the syntax of them continuously so that we know the difference between it. And you don't need to write 1000 lines of code in Python or in R. And therefore, if you just note the definition of them, how the variables are created, it's enough. So we will not download Python because you just need to search in between, and it's best to use Google Colab. Okay? So this is an example of a notebook. If you have ever used Jupyter Notebook, you can use Jupyter Notebook as well. But if you are a beginner, try to do it with Google Colab. This is a list of the pages. Just go to the recent one. Make a new notebook. So the name of my notebook says untitled2.ipynd. So this pynb, I stands for me and pynb stands for Python notebook. But what if I want to use R with it? So here's example. This is the Google Collaborative for Python, and then we will see how it will be working with Python and R simultaneously at the same time. So you just type in Google Colab, click on the first link, make a new notebook, and this is our code playground. So in case of R, it was 2 to 3 sections and you script, but in case of Google Colab, it just looks something like this. And you don't need to worry about comments because there are two options. Either you can code or write a text. So text will be executed as a comment in Python. You don't need to use a hash sign or anything. And in case of code, you just start writing your code. Now when we use R, when we use Google Colab, what happens is that Google provides us with a sufficient amount of RAM and storage for free. And this is how you can just look at the RAM amount and disk amount used by you. The RAM and storage which can be used by you. And when you upload files in Google Colab, it's the same as R. You don't need to set the working directory. But what happens is that if you just close Google Colab, open it again, you need to upload the files again. So just store it somewhere else. So imagine I need to use this library called pandas in Python language. What will I do is I will go to the pandas web page, install one. This is a command. I will just type it into Google Colab using an exclamation mark. So when we try to use
install pandas.
No, actually pandas is already there in Google Colab. You don't need to install it. It's just for demonstration. You don't need to do it, but whenever you try to do any execution for control command, you need to type in an exclamation mark. Otherwise, you can just type in your code as it is without anything. So I imported pandas as query. And now what if you want to use Google Colab for R? So there is another thing for it. You just need to go to the runtime and change runtime type. So you can just change it from Python 3 to R. Click on save, and then you will see. You know one thing, let us start with the machine learning explanation first, then I will show you how to implement Python and then develop the machine learning algorithms together in Python and R, both of them. So I talk with you about the algorithms and so what do I mean by an algorithm? It is a step-by-step procedure which is designed for solving problems. So when I talk with you about the phone book problem, I implemented a step-by-step procedure. My first step was to turn through the pages one by one. My second algorithm was to turn 2 pages at a time. And my third algorithm was to divide the book in half and work accordingly. And this is what we mean by an algorithm. It is a step-by-step procedure designed for solving problems. And we try to implement the best algorithm possible depending upon our problem. So how do the machine learning algorithms work and how are we able to implement any kind of an algorithm? So the first step is to collect the data, and for this class I will be providing you with the data and therefore you don't need to search for it. Next step is data pre-processing, which we already did with R, and later on we will be doing it with Python also in order to compare the syntaxes of both of them. And then what we will do is so when we discuss about all the models which have been implemented in machine learning, we will look at our data and choose a model accordingly, which will be the best suited model for our case. And in some cases, what we can do is we can combine multiple algorithms in order to reach the best state. It is possible to do so. So how the machine learning algorithm works, and then we choose a model. And then we train the model. So when I say train the model, I am not trying to implement the model from scratch. I am not designing the model. I am using the model and keeping it on my data. So I provide it with the data, I provide it with the model, and it combines it everything for me. And in the rest, we predict. So machine learning is widely used for prediction of data in a lot of cases. So which are the types of machine learning? It is determined by the quality and the quantity or the type of data that we have. So when I talk about ML, I have one thing called as supervised learning. In supervised machine learning algorithms, we come up with a direct notation of direct proportion. So when one thing is increasing, the other thing is increasing as well, like the age and the salary of the person. And in indirect notation, the one is decreasing and the other is increasing, like the people required to do a task. The more people that we have, the more faster the task would be continued, and therefore this is indirect, this is the direct. So in machine learning, supervised learning, we have the data. So consider the age and salary of the person. They both are in direct proportion with each other, and therefore we implement the models accordingly. Then we have something called as unsupervised learning. machine learning models. In case of unsupervised learning, we have unlabeled data. We just don't know about the data, and what we do is we provide everything to machine, and it just generates some valuable information from the unprocessed data that we have. So these are the two types of machine learning algorithms. We will look up after them step by step. But so like what is the need of machine learning? So we know how to develop algorithms, we know how to implement them, but there is a vast need for machine learning in the industry. So in any company that you see, LIC policy or any car company, they need machine learning and they use the algorithms in order to look at the customers, how to deal with them, and which are the best suitable things that they can carry out. So this can be done like prediction for a company. Next up we have NLP. So natural language processing. An example of it is ChatGPT. You can just log in there, and when I ask Google to provide me with a summary, or when I ask Google to write an essay about my father, if you just look into your class, all of your answers would be the same, because Google is not providing me, but actually someone else provided Google with some information, and it is just transferring the same to me without looking. But in case of ChatGPT, what it does is that it generates new text because it is able to mimic human brain, and by mimicking, it is able to do some things or a lot of things which we as humans do.
But when I use that essay, so I learned what the topic was and he wrote me an essay. Then I went to school, my friend also had the same.
Yeah, so you can just type in a command that I need a unique essay, and it will generate it for you. In some cases, it just provides you with an answer in the beginning. And if you want it modified, if you want it to be something unique, you can ask it, make it unique, and it will generate it the same time. It will generate the same thing for you 1,000 times by changing the context of this.
Krishna, we are 38 people, or 40 people here,
Yeah.
and if we all started to teach that write a printed word essay on accident, so will it be same for all, or it will be good? How would it be?
Because
The command is same, and how will they know that my perception is different from his perception?
here in front of you, I told Google to write an essay on AI, but Google is not providing me with an answer. It is directing me to another website. So another website is doing it for me, and if you just open it, your classmate can open the same website, find out the same answer. In case of ChatGPT, what it is doing is that it is generating an answer. In some cases, it provides the same answer to you also and him also. But if you just ask him again that I need to summarize it in like some less words, or you need to make it unique, I can just show it in front of you. So first, I will ask it. So it directed me to a website. So this is an answer, but this is not an answer provided by Google. This is an answer provided by Leverage GDU. So this is another website. It is just taking in my query and directing me to another website, which used to be an answer of my question like 10 years ago. But now I have something better. So it wrote an essay for me. It is not directing me to another website. I do not need to click on another link. It is providing me with an answer, just like anyone would ever do, any other human would do. And therefore I can just ask him like, right, establishing the potential of the future, and when I asked it to make it a unique essay, it did the evolution of artificial intelligence, a journey to the future. So both of my source results are different, and I did not have to do it in another website. If some people try to do it at the same time, it is first providing me with an answer. So my answer would be same in some cases, but when you try to generate something unique by you wanted to know that you want to make it unique, it will do it for you. There's no problem.
How many times it will do?
You can just try it on. If there's no limit for it, it may ask you to pay some money.
Obviously, there will be some basic background for this, na?
Sorry?
On what concept it is working?
It is working on NLP, Natural Language Processing. So it is thinking like a human being. Google, on the other hand, is not thinking like a human
That is
being.
fine.
It's just
But there is some algorithm that they are using, na?
I will explain the algorithm. First, I try to explain about what is it, so that you know how it works.
ChatGPT, like me and say on AI. What he's writing and what he is getting answer and
Just read the headline, which is got.
write an essay on AI. What was it? You wrote it, write an essay on AI. Okay.
It gives you different answer because it is, if you write an answer, if you try to summarize something, write it and you write it again with your own thinking, you may not be able to do it. You can do it differently. Yeah, you can use different words, you can just sum up everything in another manner. This is how ChatGPT works. If I ask Google to provide me with something unique, it may not be able to do it. This is an example of a machine learning algorithm, and we will be implementing it. But this was to show you that ChatGPT and Google are two different things, and you cannot blindly follow Google at all times. This is the most advanced thing, and therefore, at times of need, you just don't stick to Google, you can stick to ChatGPT also.
No, but ChatGPT does not have real-time data.
So you can try on another website also. This is not for real-time data, this is for making an essay. For real-time data, you can search for the same thing on Google, it will provide you with something else, and you can do it in another manner. So this is how you search for things. Yeah?
Another difference between Google and ChatGPT is Google is like a bibliography. You know, you could write something on AI or write, then they will give you a number of options to go through. It will not write as an answer, but it will just give what is there in their bibliography. But ChatGPT is giving you an answer. You don't have to read so many websites and then write it. These are the differences.
Depending upon your problem statement, depending upon your need, you can use anything which you want. It is not, so in the next year another version of ChatGPT may come, and therefore you can use it accordingly. I told you how to, Google will not be able to make a presentation for me, but as I told you about the website which is able to do it, you use it for making website, you don't use it for generating an essay. You use Google for data, use ChatGPT for essay, use the presentation website for making presentations, and this is how you work with technology.
But it was not coming.
Yeah? Copy.
No, I mean here. Copy, I mean here.
So there are a lot of websites. You can just write an AI presentation maker. There are tens of websites which you can use. So a lot of websites are not free. They just make you 15 pages for free and then charge you. So if you want something like OpenAI, that is OpenAI. When you want something like you can search for it. So OpenAI sponsored, and therefore I can make a notation that it may require some money. And when I just slide down, and you find like Canva is a great app for and it has ChatGPT also. You can use it accordingly. It is not possible. It is not compulsory for you to stick on Pop AI only. I showed you how to write like free AI presentation maker. You can search for free AI video maker also. So like InVideo.io, Hyper AI, free AI video generator, and this is how you use artificial intelligence in order to get answers for your questions. Not just questions, but to do your task more efficiently. This was an example. ChatGPT was an example of NLP. So self-driving cars like from Tesla. This is another example. So this is the need of machine learning. And if you are scared saying that AI is going to replace humans, the thing is, human beings are not born to drive a car and earn for themselves. We are in this world for doing something unique. Okay, so they develop these cars, and at the same time, they have also developed some unique websites which can perform art for us, and this is a problem. Because I was supposed to do the creative things while AI was supposed to drive a car for me, but it's doing both of them at the same time in this era, and we can just hope that it stops sometime so that we are able to distinguish between us and AI. So when we talk about a limitation of machine learning models, you can think of data. So the amount of data that is available. If you want to use any machine learning model, you can just type in on Google data for a company, for an LIC company, and the data will pop up in your screen. But there is no evidence that data is correct or not. But if you use clean data, processed data, your machine learning algorithms will work fine. Like data and machine learning has in case of numerical, I have discrete values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in case of categorical, it can be gender, like girl or boy, true or false, yes or no. So these are the two types of data in machine learning. So there are another set of algorithms for numerical data. There are another set of algorithms for categorical data. And therefore, depending upon your data, you can just switch in between your algorithms. But in case of categorical data, we come across a dummy variable trap. So what is it? Imagine I write in front of you, boy. So these are the two types of categorical data that I have, and I write in front of you that what if I say you that the person is not a boy, so I can easily say that the person is a girl. And therefore when we try to depict the categorical values like for boy 1 1 0 0 0 or 0 0 1 1 1, it is actually exactly opposite of each other. So when I use both of them in my machine learning algorithm, it will be like turning one switch on and then turning it back off. So it makes no sense. And when we have to deal with the dummy variable trap, what we do is we find out the categorical data and see if it's the exact opposite of each other, and we exclude one of them. So we turn on the switch, we don't turn it off back again. It's like taking a step forward and a step backward. The algorithm will be lost in such a manner. So as we get syntax errors, this is like a syntax error for machine learning algorithms. Dummy variable trap.
So does it categorize it as a word?
Yes and no. So remember I told you about the truth table, right? So in case of, imagine I have a data set. This is the name of the customer. Okay, so this is like the salary of the customer, and the gender of the customer, like a boy and a girl. So in this data set, the salary would be 10,000, 20,000, 30,000. Boy, boy, not a boy. Girl, not a girl, not a girl, girl. So these two columns are exactly the opposite of each other. So this is like turning a switch on and off. And therefore, when you provide these values to the data set or the machine learning model, it just gets confused because firstly we try to say something else, and this is an exact opposite of each other. So therefore, this is called as a dummy variable trap. It is only seen in categorical data, not in numeric data. So what we do is we just consider the value of boy only or the value of girl only, and then we predict the model, and it works fine. So these were the predictions, these were the problems that people faced, and they find out a solution for it. So this is a question, and here's the solution. So like excluding one of the values. So like yes or no, you just exclude one. So we will be starting with supervised learning, and an example of it is like a graph, wherein the x-axis is the age, and the y-axis is the salary of the person. So at some point we know that if the age of the person is 100 years old, their salary is not going to be very, very high. But we only consider the data set which is provided, and therefore just 25, 30, 35, 40, 45. So our graph is made like this. This is 18,000. 40,000. And I have a lot of data sets like the age 35 and the salary. And therefore, when we plot a graph of all the data that we have for supervised learning, an example of this like age and salary. So as the age increases or the experience of a person increases, the salary increases. So we don't plot everything. This is the data set. I am not mathematically calculating the age and salary of the person. This is according to my data set, and therefore what I do is I just generate a line from my data set. So a formula for a line is y equals mx plus c, and this is how I generate a line through my data set. And therefore now I know that if the age of the person is somewhere here, the salary of the person can be predicted. The predictions are not 100% true, but we just need to find a prediction. We do not want to be 100% true. Like predicting tomorrow's weather, it may be not 100% true, but in some cases it will be very, very close to the real value. And this is what we are trying to predict. So in case of machine learning, you come across data set like these, wherein there is a linear connection between both of them, x-axis and the y-axis. So what you do is, you just find a value for x to determine the salary of the person. You just find they give you the size of the plot, and you determine the price of the plot. So this is an example of supervised machine learning. I know the size, I know the price from the data set, and I just revise it and to make a prediction about it. Two different data types. One is numeric and one is categorical. In machine learning, we use regression models for the numeric data type, and the the model
Classification.
categorical data type for the classification models. So an example of classification model would be email model. So when you try to check your mail IDs, it generates if the email is spam or not. And in case of regression models, it just generates the price according to the size of the plot. So if you have categorical data, you want to know the yes or no value, you want to know the gender, like if it's a boy or a girl. In some cases, you use the classification models. And in case of if you wanted to learn the price of the plot, or in another case, if there is an x value of age and a y value of height, you can use the regression models here. And classification is just two values, yes, no, girl, boy, or something like that. So email being spam or not, so you just get two values. Email is a spam, yes. Email is not a spam, no. Like the classification versus regression. Okay, so classification and regression. The output for regression is discrete values, like the price which increases. So a price can be any value between some real numbers. And in case of classification, it would be yes or no, boy or girl. So an example of classification would be email spam, and an example of regression would be price. Side. Right. Therefore, in the linear regression model, I have these two variables, age, which in bracket is experience, or the salary of the person. This is an example of a simple linear regression wherein I have only two values, and therefore when I predict the linear regression model, I can plot it a graph also. But in case of multiple linear regression models, we have multiple values, and therefore these are not just x, y, but a 3-dimensional or 4-dimensional graph, more than 4-dimensional, and therefore the computer is not able to present a graph of it like this. And what we do is we just predict the values and compare it with the real values. So linear regression is simple linear regression, multiple linear regression, polynomial linear regression. So in case of polynomial linear regression, it is something like this. So the exponential values 2, 4, 6, 8, 10, and therefore our line is not straight, but rather is in the shape of something like this. So it is possible to draw a graph of the polynomial linear regression and the simple linear regression, but in case of multiple linear regression, it is not possible. So as you can see, this was like the age of the person, salary of the person, and the line needs not to pass through the origin O, but rather we need to determine the slope of the line and where it cuts at the y-axis. So in this